The best way to go about solving exercise 4 is to follow the Node.js implementation. So we're given some string, and if it starts with I'm positive, then we just want to replace that with I think. Shouldn't be too hard, but it's going to be helpful as it will help you get more familiar with lists, as strings in Haskell are just lists of characters. So if we go back to the server we're writing, we can just add another handler, and it's gonna look like the handlers we were writing before. And this file is getting a bit out of hand, but we can fix that later. So let's call this one string manipulation handler, and it still takes a request and returns a response. Nothing new over there. We have to register it, and the path this time is going to be this. So how do we go about solving this? The first thing I want to do is import the list module, as strings in a Haskell are lists. So that's going to be useful. And if we want to follow the JavaScript implementation, the first thing we want to do is take the prefix of the string we get as an input and see if it matches the string we're looking for. So in order to do that, we need to find an appropriate function in the list module. And that function is gonna take the number of characters, an int, the list that we have, which is a string, and give us back another list. So if you look at the example here, if we take the first 5 characters out of the hello world string, we get back hello, which is what we want. So we're gonna return some sort of result, but we don't have one yet. So we can just say that result is don't know. And we can say that the string we're looking for is I'm positive. And the prefix of the whichever string we get as an input is list. Take the number of characters, so it's going to be list length of search, where list length just returns the length of the list. So we can use that to return the number of characters in this string, and then we have to pass the body along. We can get the body by using the request body function, and it's gonna look like that. Oh yeah, we have to return a string response here. One thing I want to do is play around with the Debug.Trace module, which is gonna help to see what we're dealing with. So if you work with JavaScript, you might be used to just sprinkle console logs around your program while you're playing with it or working on it. In Haskell, we can do the same with the Debug.Trace module. Specifically, the function we want to use in this case is trace show ID. So whatever you give it, as long as it's showable, it will give it back to you. So essentially it's a pretty useless function, but it has a hidden side effect, which is printing to the console. Usually side effects in a Haskell are tracked with the IO type, but let's not worry about it for now. So we want to import another module, Debug.Trace as debug, and I'm interested in checking what prefix is. So instead of returning result, I could maybe do Debug.Trace show ID and have prefix printed. And if I run this and run the integration tests, you can see that I get the first n characters of the string. And we can now define the result properly. So following up on the Node.js solution, if the prefix of the string matches the string we're looking for, then we want to prepend I think and append it to the reminder of the input. So first of all, we have to get the reminder. And there is a function that is the exact opposite of take, and it's called drop. It would skip the first 6 characters in this case and return the rest of the string. So we can use it to get the reminder of the input. And we can say that if we drop again whatever we were taking for the prefix, we should get the reminder. And we can test this again with Debug.Trace show ID, see what we get. If we run the tests again, we get the reminder correctly. So we're now ready to get the result. And result is if the prefix matches the search, then we want to prepend I think and append it to the reminder. Otherwise, we can just return the input string unchanged. This plus plus operator is concatenation of lists. And obviously it doesn't work because I have a lowercase I. So let's fix that. So this was exercise 4. The coming up video I think is going to be much more interesting because we're going to start dealing with mutable state.